Hello guys, Assalamu alaikum.
Hello, Dr. Alaikum Assalam.
Some of your colleagues asked in the office hour about the third question in the worksheet you had last time. It was this worksheet, was this exercise. It asks you about the time at which the missile hits the plane, or whether it hits at any time. May not hit it if there is no solution. So the clue was there with you, how to solve these equations. These are the vector function representing the motion of the missile, the first one. This is the first, the second is the vector function representing the motion of the plane. So assuming hypothetically that they will come into contact, this means we have the same point. This missile will hit the plane. The plane is moving in a circle, as we discussed that last time. It is moving in a plane z equals 4. With these two x and y, we can omit or eliminate the cosine t and sine t between them. So you get an equation of a circle. In fact, it is an equation of a sphere, but its intersection with this plane is the circle, I mean. So the plane is moving in a circle. The missile is sent in this line. We equate x of the missile with the x of the plane, and equate y of the missile and y of the plane, the z as well, but we don't get any thing from this because z is 4 in both cases. So we have only two equations. We need to solve these two equations simultaneously in the same time, I mean. So the same idea, how to get rid of this cosine and sine. They have the same coefficient. Just move this 5 to the left and move this -3 to the left and square and add both equations to get rid of the cosine and sine, because cosine square t plus sine square t is 1. So we get here 4 times 1. Therefore, we get a quadratic equation. The rest is algebra of secondary school or less, maybe middle school. We get an equation in t, second degree equation, or the t square may cancel. They will not here, but we have all cases are open for solution. If we have imaginary solution, we have to mention that clearly, because some points of the grading are put on these comments. We don't have any real solutions. This means physically they will not hit. So the algebra translates the situation and give us the required solution. So we may have a time when they hit, when the missile hits the plane, or t is imaginary. This means it will not hit at all. Any question?
Doctor, I wasn't here 5 minutes ago, so I'm not really sure what are we talking about. Is that's the same question that we tried to solve the last time?
Yes, it is.
Oh, okay.
Very similar, but the only difference is the argument of the sine and the cosine is pi t. It will not matter. The important thing is to have the same argument, the same angle, and to have here the same coefficient, 2 and 2. I'll make it a bit complicated. Say t minus 2 is 3 cosine t, and 3 minus t equals 2 sine t. Say, another example. What is different here? We have the same situation. We need to solve these two equations simultaneously. The same idea. We need to get rid of the cosine and sine t. How to do that? The idea is the same. Cosine square plus sine square is 1. But we have here different coefficients. How to get rid of these different coefficients? Any idea? Shabab? Very simple algebraic tricks or maneuvers. You may do it. We get rid of the 3 first. We need to, yes, go on.
Multiply the 3 by 2 and the 2 by 3?
we multiply the first equation left and right by 1/3. We get rid of the 3, divide by 3. Divide the first equation by 3 to get 1/3 or 1/3 t minus 2 equals cosine t. The second need to be divided by 2. Why all of that? Because the relation is cosine square theta plus sine square same theta is 1. We have to have the same angle. We don't need to have a different coefficient here, 2 here or 1 here, no. We don't need that. So we have to get rid of the coefficients first. But if they are equal coefficient, we don't need to divide, like the case we have already. We have 2 here and 2 here, 3 here and 3 here. We don't need to get rid of the 3 because it will be taken as a common factor. But they are different. We have to transfer them to other side by division. Then this is 3 minus 2t equals sine t. The same idea will work again. What to do? Square both sides. What else? Add both sides after squaring. We will get rid of the cosine and sine, but you need to work carefully because of the fraction, then you can get rid of them at all. I'll finish this. Don't worry about the fractions, but work mathematically, not with approximation. You need to do it exactly. This is squared plus this as well, 3 minus t. Compound square, all square. Here we'll get 1. Now we get 1/9 here and 1/4 here. We can get rid of all of that by multiplying by 9 times 4. 9 times 4 to get rid of all of this. Therefore, we get 4 times t minus 2 square, the 9 gone. Here, the 4th gone with 9 instead. 3 minus 2 square equals 36, which is the 4 times 9. The rest is easy. You can do it yourself. Just, I'm trying to let you be familiar with the algebraic manipulation we usually do. This, you can gain this, or you already have it by working by your hand every day of lecture and the day of submission of your web assignments. Any question? Got it? So don't worry about the angle, pi t, pi over 2t, 2 pi t, whatever. The important thing is the same angle. Any angle theta satisfies this important identity. So we can get rid of the cosine and sine. Questions? This was the question of your colleagues at the office hour. Now we'll go to the new section, which is section 13.2 about derivatives and integrals of derivatives and integrals. We take the domain limits the last time. Today is the next step, which is derivatives and integrals. Integrals or integration of vector functions. What is a vector function? Vector function is usually written this way, RT, which is scalar function of t, scalar function x of t, scalar function y of t, scalar function z of t. So we have, what we have, 3 functions of the same parameter t. Think of t as variable or parameter representing time, which is the independent variable of all of our life. If t represents the time, then r of t is what? You can remind us. the position vector of a moving particle on a curve in space, on a curve in 2D or 3D space. Okay. In 3D space, mean XYZ, or 2D if Z is 0. If you are given Z is 0 or not given Z at all, so we are moving in plane, some particle moving in plane. What about how to differentiate? How derivative, you mean, you know, derivatives or differentiation. The other name, differential calculus or differentiation. In calculus 1, we used to have this, d by dx. Here we have many of these. In calculus 3, we have d by dt. We have, when we have functions of many variables, we will have d by dx, d by dy, d by dz, and all of this stuff. You know that the derivative, definition of derivative, as usual, you have it in calculus 1, calculus 2 as well, which is, you remember this, f dash of x, f prime of x, or dy by dx, same, different notation for the same thing. It is a limit. For this, we revised limit last time. Limit f of x plus h, the value of the function after some change, minus the value of the function before the change over this change, when this change is infinitesimal, tends to 0, small change in x. This was the definition of derivative in one variable. We have one variable today as well, but 3 functions at once. What this means, I need you to remember this this is very important to remember. What is the meaning of the derivative? Meaning of derivatives. Who can remind us of the meaning of the derivative? Geometrically, this is easy. It is what? The? Okay. Slope, yes.
Slope tangent
exactly.
at a given point.
It is the slope of the tangent at the point. It is the slope of the tangent to the curve of this function. Of the function at the given point. We are given point or points, and so on. This is the meaning geometrically. Slope. What else? Physically. Physically or any other fact, not only physics. In physically means in any application. It is used to as the word of rate of change. It is, the derivative is the rate of change. It is the rate of change of y with respect to x. Importantly, a special case of physically, which is we are interested in today, is dynamically speaking. When we have a particle moving, if we have this r of t as x of t, y of t, z of t, we think of a particle moving along a curve in space. This is the origin, O, and this is the position vector of the moving particle. Moving particle here. At time 0, it begins from here and move this way, move in this direction. This is R at time t. This is R another time. This is R at other time T1. Let this be T1 and T2 and so on. So what do you think of R dash of T or dr by dt? It is, we differentiate x with respect to t, y with respect to t, z with respect to t. This is maybe written x dot, y dot, z dot. This is another notation, nice simple notation if you like. What this is, it is, we cannot say the slope because in 2D it is the slope, the rise over the run, delta y over delta x. But in 3D it is not we cannot say slope in 3D, but we say the tangent vector. So this is the tangent vector. We have 3 components. So this is R prime. R prime of t is tangent vector. Same ideas of calculus 1. So we remove R2 from here. We will be asked to sketch or draw them. Draw R1. This is R1. R at T2. This is R dash at T2. This is R T1 and so on. Here, the derivative here is this. It will be red. This is R dash, the tangent vector at T1 and so on. So as the particle moves, R changes and the tangent vector changes. We will be interested in this tangent vector and its unit vector as well. We will study it in the coming lectures. We will calculate this tangent vector and its unit vector today, and we'll have more studies on it in the coming lectures, inshallah. Any question? So dynamically speaking, R dash is the tangent vector. It represents, this represents R dash T represents what? Who knows? Who studied physics? If this is a position vector, velocity. Yes, velocity, exactly. The velocity vector V of t at time V at time, velocity at time t. So this is very important to keep in mind. V of t is R prime of t. Or you can write it like this, the notation you like best use. This is the first derivative at time t. It is in the tangent direction. Or direction of the tangent, and so on. Also, we can also, as usual, as in calculus 1, we can make second and third derivatives and so on. We can also find R double prime of t, which is the
acceleration.
The first derivative, what?
اللي هي اللي هتبقى الاكسلريشن صح؟
Exactly, yes. Which will be the first derivative of velocity. So this is R double prime is V prime or dV by dt, or the other notation d to R by dt squared. So differentiate R twice. To get what?
The acceleration.
Acceleration. Of motion of this particle. This is what about differentiation and its geometrical and physical and dynamical meaning. Now the opposite of this is the integration, as you know. So if we differentiate the position vector, we get the velocity. If we differentiate the velocity, we get the acceleration. If we are given the acceleration, we do what? If we are given, yeah, if we are given the acceleration or r double prime, we do integration. We do the opposite operation. And the other operation, the opposite. Inverse operation of differentiation is, as you know, is the integration. The inverse operation of differentiation is the integration, which used to be this. F of x dx gives you antiderivative of x plus constant. This is called antiderivative. The function or the thing we differentiate to get the little f. And the c is what? What we call it? Constant of a integration. This is very important. The same situation here we have this example. Let's take some example on this. If we have 2 cosine t, sine t, and 2t with respect to t. So this is integration of some, let it be f of t, f a vector of t, dt. If it may be the acceleration or anything. So what to do here? So we do 3 integration at once, as the same we have done last time with the limits. We do it today with the differentiation and the integration. So we go inside this vector function and integrate the x component with respect to t, the second y component with respect to t, and the third z component with respect to t. This will give you what? 3 integrations at once. So who can remind us with the laws of integration? The integral of cosine is?
Sine.
Sine.
Sine, exactly. 2 sine t plus c1. And?
Cosine.
Negative
The
cosine.
signs, yes, we know it is negative. Why? Because the derivative of cosine is negative sine. So we have to put here negative sine, negative cosine t plus another constant, c2. Here, 2t, the integral of t with respect to t is t square. We divide by 2. So raise the power by 1 and divide by the new power. So it's t square. 2t square over 2 cancel plus c3. The new constant of integration for the third integral. We can write it simply like this. We can get rid of all of these 3 constants and put them outside as one constant vector. 2 sine t minus cosine t, t square plus c, where c is, we used to have scalar constant of integration because we have scalar function. Now we have vector function, so the constant is constant vector of integration. Constant vector of integration. You can write it directly without doing this system, which is C is C1, C2, C3. One constant for each integral. So what we have here is very natural. We extend our knowledge of differentiation and integration from scalar function into vector function. So we do what we used to do 3 times at once. Where to use this? You may be given remark on this integral example. This is if you are given r double prime, the acceleration, so this will give you the velocity. This is the acceleration vector, which is r double prime. Then we get the velocity vector r prime plus constant vector. Then again, this is the integration. Another integration will give you the position vector. R of t is the position vector. Integrate again with respect to t to get the position vector. Plus a new vector, a new constant vector. So every integral, as we are used to, every integral gives you a scalar constant of integration. Now we get a vector constant of integration. How to find the value of this vector or this constant? As usual, if we are given initial conditions, we can find and evaluate this constant. This is what? Constant of integration. But to be noted, it is vector constant of integration. So again, to recap, if you are given the position vector, we differentiate to get the velocity, we differentiate again to get the acceleration. If you are given the acceleration, we can integrate to get the velocity, we can integrate again to get the position vector. But be careful not to forget the constants of integration. Let's go for another example of differentiation. Example, let's go for example in 2D first. Given r of t, this square root of t in the direction of I plus 2 minus t in the direction of j. Of course, this can be written as, without the ij notation, as vector notation without the ij. Root t as the first component of the vector, 2 minus t as the second component. This is the second method. You are given this or that, not both. They are the same thing. So particle moving into D, we are given I, this is the x-axis, this is the y-axis, I is a unit vector along x, j is the unit vector along y in the positive direction, as usual. The question is, find r prime of t, sketch, need to be used to this sketch thing, sketch position vector, and tangent vector at t equal 1. So the question is, after 1 second, where is the position vector? Where is the velocity vector? May be written in symbols or sketch r of 1, r prime of 1 at the time 1. So this is easy, direct computation of derivatives. We are given that R equals root T here to minus T. We need to find R prime directly, as we have done with integration and limits before. You go into every component, point-wise differentiate. Mean differentiate the first component, X with respect to time, and so on, Y, Z, and so on. So who can remind us with the derivative of the root T with respect to T?
تبقى 1/2 root T.
Yes? This is important. D by dt of root T is 1/2 root T. This is important formula. Saves some time as instead of doing T power half and half T power half minus 1 and this stuff, this is direct computation. Exactly. This is, if you need to, from where this formula comes from half T power, half minus 1 is negative half, therefore it is half 1/T power half, which is 1/2 root T. So it saves time if you know the derivative of the square root directly. So it's 1/2 root T. Of course, T has to be bigger than or equal to 0 in the first given equation. In the second, it has to be more than 0 because of the constraints of the domain. The derivative of y is easy. Derivative of 2 is 0. Derivative of minus t is minus 1. This is the tangent vector or the velocity. This is the position vector. This is the tangent vector. If he asks, I'll add some other question. Tangent vector, unit, let it be unit tangent vector. Unit tangent vector. This is important. It has a special, it is capital T is a unit tangent vector, not R prime itself. What is the difference? This is the tangent vector. From the tangent vector, we get the unit tangent vector. Unit tangent vector is capital T. It is R prime over magnitude of R prime. This is the way you get a unit vector in any direction. You know that? For any vector. For any vector A, the unit vector, for any unit vector, for any vector A of any length. If you divide by the length of A, you get A. It has a special symbol. I'll show you. It has this symbol of A cap or A hat. A is the vector A divided by magnitude of A. It has the same direction as the original vector, but when we divide by its length or magnitude, we get a unit vector. So when we are asked to find the unit vector, we divide this vector by its magnitude. So we are asked to draw all of that at the time t equals 1. So let's compute this. T, R prime first. R prime of 1. So substitute for t equals 1 to get 1/2 and minus 1. This is the tangent vector at time equals 1. T at 1 is R prime at 1 divided by its magnitude, the magnitude of this vector. You know the magnitude of the vector is given by Pythagoras formula.
Half squared plus negative
When
1.
you have any vector A given by AB or XY, so its magnitude is what? Yes, again,
Is it half squared?
square root of A square plus B square.
Yes.
This is A, this is the B, so you apply Pythagoras theorem. The magnitude of any vector is the square root of the squares, sum of squares of its components. So this is vector half and negative 1 divided by the square root of square all these components, so you get 1/4 plus 1. To simplify this, we make common denominator here, we get 5/4. 4/4 instead of 1 plus 1/4 get 5/4. The square root of 5/4 is 2/√5. So we get 2/√5 times this vector 1/2 -1. We can multiply the 2 inside to get rid of this fraction, or leave it as it is, no problem. 1/√5 times 1 n minus 2. This is the unit tangent vector at the time 1. Where is the position vector at time 1? We didn't compute it. Okay, let's do it. R at 1 is R at time 1 is what?
√1, log 1.
√1 is which is 1, 2 minus 1, which is 1. So we have two vectors to sketch. He asked me to sketch the position vector at 1 and the unit tangent vector at 1. So we need to sketch what?
The unit tangent vector will position vector.
Sketch R of 1. R of 1 is what? This 1 and 1. The vector 1, 1. T of 1, which is this 1/√5, 1 minus 2. Of course, if he didn't ask about the unit tangent vector, we use only this R prime. We use this. I think the question in your textbook asks for the tangent vector at 1. So he means this, but I make it a bit complicated and asked for the unit tangent vector. It is the same direction anyway, and we will not measure it exactly. It is only the directions. So now we need to do what? This axis so when t is 0, when t is 0, R is, so let's go to the original position vector function, root t minus 2 minus t. So root 0 is 0, t minus 0 is 2. So the initial point is 0, 2. This is the original point. This is the beginning of motion, 0, 2, the point 0, 2. At 1, we get this, 0.11. So it moves here from this initial point 0, 2 up to 0.11. Where is the position vector? This is R at 0 times 0. This is R. This is R at 1, going to the point from the origin to the 0.11. And where is the tangent? Where is the curve? First of all, let's draw the curve. The curve is this, going from this initial point to this point and going down. You are not asked more than that. I'll give more questions about it. Where is the tangent vector? The tangent vector would be drawn like this. Here is the tangent vector. Whether r prime or t, I will not measure it exactly, but just to show where is the position vector and where is the tangent to the curve of motion. You get it? Any question? Okay, one more question. Algebraic manipulation about the problem. Prove that this particle moves in a parabola. So for this, we need to revise some algebra and geometry, so we need to work hard, please. So question. Prove that this particle moves on a parabola. What is the parabola? Can someone of you remind us with the parabola? What is the parabola?
Is it
Yes, simplest equation of a parabola. No problem.
X squared.
Yeah, what is x squared?
The curve of x squared is a parabola, right?
Yeah, you need to say the whole equation. Y equals x squared.
Oh, okay.
Okay, y equals x squared is a parabola. If we can move it up and down and this stuff, it is the same as parabola. What one other parabola is the parabola open to the right, open up. If it is negative, it's open down. Here, open right. Here, what will be the equation?
x equals y squared?
X equals y squared, and it can move left and right and all of this stuff. So we need to prove that this vector function, this parametric representation of the vector function actually represents a parabola. How to prove that? So let's go from the beginning, write R as separate. R equals 2 root t, root t, 2 minus t. So we need to get rid of this t. The idea is we need this y equals x squared or x equals y squared or any similar forms. So we need to get, so our x is root t. Our y is 2 minus t. So this is called, or these are called parametric equations. Parametric equation of the curve or the parametric equation of motion of the particle, whatever to say, how to say it. Now we need to get rid of we need to get x equal y squared or y equal x squared or similar forms without t. So we need to get what? Get rid of t between these two equations. The same way we get rid of the cosine x or cosine t and sine t in the example of the previous lectures between the equations. Any idea? There we squared the cosine and squared sine and added them. Here is easier. We need to get rid of t. So substitute what? Any idea? What is the relation between t and root t? What is the relation between t and root t? T and root t.
If we square root t, it will be t.
Exactly. This is the idea. So x squared equals t. Square the first only. And substitute. Substitute into 2. This is 1. This is 2. Substitute into 2 to get what? Y equals 2 minus x squared. which is a parabola. This is, but we need to draw it carefully to see how it goes. If it is y equals x squared, it is open up, as you said. If it is y equals minus x squared, it is open down. Y equals x, negative x squared is open down and added to up. So when x equals 0, y equals 2. When x equals 1, y. When x equals 1, y equals 1 as well. So it's 1, 1. Here 2, 0, 0, 2 asif. X first, of course. If I made a mistake, if I make any mistakes, please tell me. When x is root 2, y is 0. Here the point is root 2 and 0. And this is the curve of the parabola. This is a parabola, but not in standard form. It is shifted up. It is open down and shifted up by 2. There is another branch of this parabola to the left, but we are not interested in because this represents a motion when this point is at t equals 0. This is the beginning of initial point. And you may be asked as well to show the direction of motion. The direction of motion is in this direction. This is the direction of motion. How do you know? This is t equals 0. So begin from here and goes this way. Direction of motion. And so on. This may be a projectile or a missile or this stuff, all of this. Our question was to draw the position vector when t equals 1. This is when t equals 1. The position vector was here. This is r at 1. And the tangent vector is here, t. All we are asked for just sketch, not precisely making exact drawing or using a computer algebra system or advanced drawing calculator or grapher, no need. But if you have it, no problem, it will show you a bit more. Any question? Let's finish our lecture by an example in 3D. This is, the situation is the same. We differentiate x, we differentiate y, we differentiate z, and we may be asked to sketch part of the graph and the position vector and the tangent vector at a specific point or points. So let's have another example. In 3D this time, let R be 1 plus t cubed. This is the x coordinate of the moving particle, t, e minus t. So the functions we studied in calculus 1 and 2 are coming in to be differentiated and integrated and find their limits and this stuff 3 times in every function, in every given function, because the fact our functions now are vector functions, 3 functions in one at once. Sine 2t. Rules of differentiation always work. The question is find r prime, r double prime, and he asks you what do they mean? Of course, we know now, we know even before what the derivatives mean. The slope of tangent if we are in 2 dimensions, or the tangent vector if we are in 3 dimensions. What we say in 3D applies to 2D, but what we say in 2D not necessarily apply in 3D because we have more dimension. And we don't have the concept of slope in 3D. We have tangent vector concept. Question 2, find the unit vector. Find the unit vector at t equals 0 at the beginning of time. So this is no new things of this, but only the revision of differentiation and rules of differentiation. So you need to write the formulas you need in this in the lecture every time and in the worksheet every time, and collect them in a cheat sheet to help you in the exams. When you write it by hand, you don't need, you may need them. You don't need them. This needs practice to get to this level. So let's find R prime. So we go inside the vector and differentiate x, differentiate y, differentiate z with respect to the independent variable, which is the time. Easy differentiation. Differentiation of 1 is 0 plus t cubed differential of 3t squared. Power rule, usual power rule. Multiply by the power, decrease the power by 1. This is the power rule for polynomial. T times e power negative t. What will this need? I think there is a rule for this, which is product rule. Product rule, which is the first times the derivative of the second plus the second times derivative of the first. So one term, one is differentiated, the other is not, and vice versa. So let's do t times derivative of e power negative t. You need to put brackets not to miss the negative sign. Otherwise, you will change the product into subtraction, which is completely wrong. Which is derivative of e minus t is the same as e minus t, but differentiate the exponent. This is an exponential function, which is -1. Plus derivative of t is 1 times the second as it is this. But this may need some simplification or common factor. Sine 2t, derivative of sine is the same as derivative of sine is cosine, but we need to multiply by what? The derivative of the argument. The argument is the angle 2t, differentiate 2t, multiply it outside. So derivative of sine is cosine, multiplied by the argument. This is the derivative of r prime. So let's write it a nicer way. E minus t, 1 minus t, e to the minus t common factor. I take e to the minus t common factor, but put it in the right because this is negative sign. So 1 minus t. Or you can write minus t plus 1, whatever you like. This is a bit nicer. So t2 cosine 2t. What does this mean? This is meaning what? Velocity vector. Or geometrically, tangent vector. Tangent vector, but not the unit tangent vector. If you need to find the unit tangent vector, capital T, you need to divide this by the magnitude of the vector. But this is asked later at certain point. Okay, second. R double prime, which is R prime prime. The derivative of the first derivative. Again, the same situation again. This will be 6t, the power rule. Again, the product rule, 1 minus t, the first without derivative, times the derivative of the second, exponential as it is, derivative of the exponent minus 1 plus the derivative of the first, which is minus 1, times the second without derivative. Third component, derivative of cosine 2t, which is negative sine 2t times the argument derivative, which will give you negative 4 sine 2t. Again, simplify. To get what? 6t here. Take again e to the minus t common factor. So we get t this time, -1, -1 will get -2. So it moved the other way again. Here, -4 sine 2t. meaning acceleration vector. This is what we learned today. Find the unit vector at t equals 0. The unit vector is R2, R dash. Let's write to find t at 0, which is r prime at 0, but don't forget to what? Divide by the magnitude of this, r of 0. Sorry, r dash, r prime. The tangent vector. This is the unit tangent vector. Unit tangent vector at t equals 0. This is the tangent vector r prime divided by its magnitude. How to do that? Substitute t equals 0 for t equals 0 here in r prime. So t equals 0 give you vector 3 times 0 is 0, 1 minus 0 is 1, e power negative 0 is e power 0 is 1. Cosine 0 again 1, so multiplied by 2. This is the tangent vector at time equals 0, but we don't need the tangent vector. We need the unit tangent vector. We don't need any tangent vector, but the unit tangent vector. The same direction, but with magnitude 1. How to make it magnitude 1? Divide by the norm of the vector or magnitude of the vector. How to do that? The square root of the sum of squares of the 3 components. So this formula is working. It works in 2D or 3D or even more dimensions. So 0 square plus 1 square plus 2 square. This is the required answer. So it's 4 plus 1 is root 5 times vector 0, 1, 2. This is the required vector. One example of
مستر دكتور ممكن تجيب السؤال اللي فات بس تاني؟
yes. اتفضل.
لا السؤال اللي فات بس آخر حاجة.
Okay. Any mistake?
لا بس كنت عايز أشوف الأنسر. تمام.
Okay. Another example. Find parametric equations. When we see this sort of question or this word, you need to be aware of it. You need to be, you need to write the parametric equations you studied before about the parametric equation of straight line, for example, and this stuff. I remind you of it, but you need to write it with your hand. To make a file for it in your mind. Define parametric equations for the tangent line. Exactly, this is the question. He asks you to find parametric equation for certain straight line. So we need to know how to write this parametric equation of a line. We need to find we need to know a point. Don't say the slope. X1, Y1, Z1, or X0, Y0, Z0, whatever. Here, what we replace the slope in 2D by in 3D is a vector, directional vector of the line. This is a line L passing through a point X1, Y1, Z1 and having directional vector A, B, C. Then the parametric equation is X equals X1 plus A T, Y equals Y1 plus A B T, Z equals Z1. You already studied this, but we need to be sure you know it and use it and can answer it. This is called parametric equations of a line. There are other forms of the equation of a line. I'll write them. Parametric equations for a line. We need to know a point and a directional vector. This is this form. Symmetric form of this line L is x minus x1 over a. Imagine that we eliminate t from these three equations. So x minus x1 over a equals y minus y1 over a over b, because this is t and the second is t, the third is t again. So the same idea of elimination is used many times. Z minus z1 over c. All of this equals t, the parameter. Eliminate t. So as if a particle is moving along this line, along this direction, beginning or passing by the point x1, y1, z1. So if you know a point and the direction of a vector along a straight line, we can write directly the parametric equation. This is a parametric equation, the ones to the left, or the symmetric equation, the one to the right. We again continue our example. Find the parametric equations for the tangent line to the helix. What is the helix? We studied it last time. We mentioned x equals 2 cosine t, y equals, may be written this way as well, sine t, z equals t. If this was constant, it was to be a circle, as we mentioned last time, but this is not a constant circle in a certain plane. This is moving, this is varying with time. So this would be a circle in a fixed plane if z is constant, but z is equals t, so it is moving. As time moves, we get this sort of shape, moving up or moving down according to the situation. And we are asked to draw, sketch part of this helix and show the direction of motion as well. So what? Find the parametric at t equals, at the point, he didn't give you t, but asks you to find it. At the point 0, 1, so the x is 0, the y is 1, and asks you about the z. Show the direction of motion as well. Show the direction of motion. So how to show the direction of motion? We put t equals 0 and decide the point at which the particle begins its motion, and find the another point, a following point, successive point, and show the direction from the initial point to the second or coming point. This is easy. Just substitution, show the direction of motion. This is sort of revision of the equation of line. So what is the direction, the directional vector of the tangent line? We need to differentiate. Tangent means differentiation. If he asks you about the meaning, it is the velocity as well. So we need to differentiate this given equation, r equals, this is the solution. R equal to cosine t, y equals sine t, z equals t. So derivative, tangent vector, it's r prime. We don't need t. He didn't ask about t, so we don't need to complicate it. Differentiate, as usual, this is -2 sine t. The derivative of sine t will be cosine t. Derivative of t is 1. This is tangent vector. We can use this vector, but we don't use it in general at any t. We need, the question is about specific point, a specific point when x is 0, y is 1, and z is unknown. You need to find it. So at point P, where 0, 1, and question mark here is to find z. This means x equals 0, y equals 1, z equals what? We need to find this. So cosine t, 2 cosine t is 0, and sine t is 1. When this happens يا شباب، امتى ده يحصل؟ When cosine t is 0 and sine t is 1. Okay.
Pi over 2.
Pi over 2, exactly. Sine 0 is 0, sine pi over 2 is 1. This is the sine. The cosine begins, cosine 0 is 1 and goes down this. Sine 0 is 1 at 0. Sine 0 is 0 at 1. So this happens at pi over 2. This means t equals pi over 2. So we decided what is the required time. And this gives us z. Z equals t, which is pi over 2. Therefore, the point P is 0, 1 pi over 2. So what we know the point, we know the tangent vector. 1, 2. Substitute it into 2 to get the tangent vector at this P. R dash at P. R dash at P. Substitute for R dash at which time? R dash at time equals pi over 2. So substitute for pi over 2 in R dash to get negative sine pi over 2 is 0. Cosine pi over, sorry.
Oh, sine pi over 2 is 1.
Yes, exactly. This is negative 2. Cosine pi over 2 is 0. This is 1. This is the tangent vector. So this is the tangent vector at P. So we have the line passing through the point B, 0, 1 pi over 2, and the direction, the vector, but this is not unit vector, no problem. It is not needed to be unit vector here. He didn't ask me to find the unit vector, and the equation of the parametric equation of a line does not need A, B, C to be a unit vector. Any vector will work because this is like ratios, A to B to C. So they can be multiplied or divided by any scalar. So L is given by x equals y equals the parametric equation. So the parametric equations of L are this. The point is 0, 1 pi over 2 plus t, this vector. The vector is put here, 0, t, here 1, sorry. Where is the vector? This is the vector. This is the vector. So negative 2 t plus 0 t plus 1 t. Of course, we can simplify it. Negative 2t, here 1, here pi over 2 plus t. You can put it in the symmetric form if you are asked to, but here it's not. The last part is to show the direction of motion, how to draw part of this helix and show its direction of motion, put t equals 0 to know when we begins. to show direction of motion, find r of 0, r of pi over 2, and draw the direction. The direction will be from 0 to pi over 2. This is the beginning, this is a coming point, a direction. Where is that? Where is r? R is 2 cosine t, sine t, and t. So we have r of 0 is, cosine 0 is 1, sine 0 is 0, and this is 0. This is the position vector of the initial point. R of pi over 2, substitute in the same original position vector given, pi over 2 cosine will be 1. Cosine pi over 2 is 0, sine pi over 2 is 1. This is pi over 2. So where is the first point? 2, 0, 0 here. This is the point, 2, 0, 0 at time equals 0. This is the point, coming point 0, 1. This is 1. Move in the direction. No, the x is 0, so we don't move. We move to the on the y axis first. No motion in the x-axis. Move one unit in the y-axis. Go up by value of pi over 2. This is the second point, 0, 1 pi over 2. So the helix here goes like this, goes to draw a circle, but going up this direction. This is the direction. And goes this way, trying to draw a circle, but doesn't finish, it goes up, and so on. And so on. From where I know that it is a circular helix. It is in the direction of z because this z is the t. Instead of the constant, it is t. So it is circle in xy. The projection of this helix on the xy plane is a circle, circular helix. If you see this, 2 cosine t equals x and y equals sine t, you can eliminate the sine t and get the equation of the projection of this helix, which is clearly a circle or an ellipse. I think it's an ellipse. No, it is not circular. It is elliptical helix. Why? Because x equals 2 cosine t, y equals sine t. The clue or the remark I mentioned in the beginning of the lecture, we need to get rid of this cosine and this sine, so we need to divide first by 2 because they are different coefficients. Here 2, here is 1. So we need to x is 2 over 2 square plus y square equals 1. This is not a circle, it is an ellipse. So we need
Doctor,
Naam.
well, I don't want to interrupt. I just want to tell you that we're a bit over time. It's for
Time finished?
yeah.
Okay, let's stop here.